Verify that the function given by y equals to sin of x plus cosine of x is a solution to the initial value problem y double prime plus y equals to 0 with the initial conditions y calculated at x equals to 0 is 1 and derivative of y with respect to x calculated at x equals to 0 is equals to 1. For a function to satisfy an initial value problem, it must satisfy the differential equation including the initial condition. So we begin by calculating y prime and y double prime. As y is equals to sin x plus cosine of x, equation number 1, we differentiate equation number 1 on both sides with respect to x, and that gives us derivative of y with respect to x is equals to cosine of x, which is the derivative of the sine function, minus sin of x, which is the derivative of the cosine function, equation number 2. We now differentiate equation number 2 with respect to x, and that gives us second derivative of y with respect to x is equals to derivative of the cosine function will be negative sin x minus derivative of the sine function is cosine of x, equation number 3. Next, we substitute both y and y double prime obtained in equation 1 and 3 into the left hand side of the differential equation to get y double prime plus y is equals to negative sin x, negative cosine of x, plus sin x plus cosine of x, and we see that the common terms gets cancelled out, leaving us with 0. Hence, y equals to sin x plus cosine x solves the differential equation. Next, we need to calculate the value of y at x equals to 0 and derivative of y with respect to x calculated at x equals to 0. For that, we consider equation number 1, which is y of x is equals to sin of x plus cosine of x. At x equals to 0, y of 0 will be equals to, replace the value of x with 0. So we have sin 0 plus cosine 0. We know that the value of sin 0 is 0 and that of cosine 0 is 1. So we get 1, and this satisfies the first initial condition. Moving on to the second equation, we have y prime of x is equals to cosine x minus sin x. So at x equals to 0, y prime of 0 will be equals to cosine 0 minus sin 0, which also gives us 1, and this satisfies the second initial condition. This result verifies the initial value. Therefore, the given function satisfies the initial value problem.